Square and square root. Square and square root. What is the square of a number? Does anyone know what the square of a number is? What's the square root of a number? Yeah.
The square of a number is a number times itself.
Okay, awesome. So if the square of a number is a number times itself, what is 4 squared? Yeah.
4 squared is 16.
16, great. So do we understand that if we square a number, we're doubling it?
Yeah.
So that's all I do is I double it?
No.
No, what am I actually doing to it? I times it by itself. Okay, very good. Pay attention. Okay, this is why when I talk in videos, I actually want you to respond back to me. Because when you speak, you actually have to, that's weird. Aren't I looking the other way?
Whoa. Oh.
Freaky. Okay, so if the square of a number means that I am multiplying that number by itself, the square root is when we do the opposite. So the square root of x is when we find a number times itself to make it. Okay, so the example here, the easiest example of if I take 100 and I square root it, this is saying what two numbers times itself equal that number. So if x squared, if this is 10 squared, gives me 100, the square root of 100 is going to give me what? 10. 50 times 50 would be 2,500. That's a really good guess. Thank you for stepping up and taking that risk. Yes. S-Q-U-A-R-E. I won't mention who asked that question. Really? Really? We're talking about colors of pens. Just remember that this is record, so if I say names, I can pull it up at parent-teacher interviews. Is this blue? All right. Now, that being said, if you want to memorize these quickly, what you're going to do is we go like this. 1, 2, 3, 4, 5, 6, 7, 8, all the way to 12. Okay? These actually become the square root of a number. The top becomes the square root. The bottom is going to be when I square it. This is a really important chart for you to memorize. And for all of you in grade 6 and 7 who get the benefit of this lovely video, do it now. You don't have to do it next year. This is why I don't like seeing myself teach. Okay. All right, here we go. What is 1 squared? 1. What is 2 squared? 4. 3 squared is? 9. Why is it not 6?
Because it's not 3 times 2.
Hold on. Why is it not 6?
Because it's not 3 times 2.
Why isn't it? That's what we
Because
have.
it's
4
squared.
2 times 2 is 4. Why isn't it 3 times 2?
Because it's squared.
Because 3 times 3 is not 6.
Okay, 3 times 3 is 9. Good. 4 squared, 16, 25, 36, 49, 64. Pretty straightforward. Does everyone follow what I've done there? Do you see that? Nod. This is what I get.
We're not that.
Do you understand what I'm saying?
Yes.
Okay. Thank you. Thank you, sir. Now, if I want to find the square root of 9, the number is directly above it. Is that making sense?
Yeah.
Yeah, you're going to say, yeah, does that make sense? So what is the square root of 36?
6.
Yeah, oh, I was asking the gentleman in the Mexican shirt. Okay. What is the square root of 49? 7. Okay, it's very straightforward that way. Okay. Now, here's where it gets interesting. I asked you guys what to estimate the square root of 71. So where would that fall on this scale?
8, 9.
Yeah, it would fall over here, wouldn't it? Now, what is 9 squared?
81.
81. So I have 64. Oh, excuse me. Lunch just happened again. It was disgusting, I agree. and it's on video. That's awesome.
Censor yourself.
Okay, here we go. So 71 is going to fall kind of not halfway. It's a little. What would halfway between 64 and 81 be?
I don't know.
Well, what have I got? I've got 6 to 70. So that's 6, 16, 17. What's half of 17? Come on, come on, come on. Half of it's around 7.5, right? So what's 64 plus 7? 64, it's like 71 around, right? So this is going to be approximately 8.4, 8.5, somewhere around there. Do you understand how I got that? All right, let's take a look at the square root of 20. Estimate what the square root of 20 would be. Don't guess, use the chart. The square root of 20. 4.6. Why 4.6? See, so halfway is, it's around there. It's going to fall somewhere around here. You see that? What about the square root of 5? Where does it fit on the bottom? We've already squared it. About 2.5. Now here, is 5 closer to 4 or to 9?
4.
Let him finish. Let him finish.
9.
Okay? 4. There you go. There you go. Right? So if I have 4, this would be 5, 6, 7, 8. Right? So it's just in that first little column. Someone grab a calculator. Could you do the square root of 5? It's going to be 4.2 something. Oh, what did I say? 4? What did I not do?
You didn't.
I didn't look at the top. Right? So the square root is going to be around 2.2. Somewhere around there. Am I right? So guys, this is called benchmarking. It's called benchmarking. So when you're estimating square roots, this is the chart you're going to be using. These are also called perfect square numbers. They're the only ones. A square root is also called an irrational number. Put in any other number other than these. Square root of 11. Solve that. See if it repeats. 10? 10? Square root of 10 will be an irrational number.
Square root of 11 is like 3.3166247.
Does it repeat?
I don't think so.
It doesn't repeat. Square roots will not repeat. It's like pi. Pi is an irrational number because it doesn't repeat. FYI, I have a grade 7 student, 100 digits of pi locked in.
Wow.
Yeah.
What?
No, it's not. So yeah, no. So here, guys, anytime we have a square, we're going to get a decimal that goes on and on and on and on forever. The only ones that don't are perfect squares. That's why they're kind of like magic. They're really important to memorize. Make sense? Awesome. Next. Do you need that? Okay. But wait, I don't need that. Yeah, you can have that. Are you going to make a hat? Only if I can wear it by the end of the video. Okay. Hey guys, I want this video to be under 10 minutes, which means I have about 2 minutes left. So here's the next thing. I want you to take a look at this sequence. And you're going to need your calculator out to solve this. 2, 3, 4. I want you to see if you can find out which of these, when square rooted, give you a perfect square. We know 100 does. What's the square root of 100? 10. Okay, check all the rest. Find out which ones are actually perfect squares. Is the square root of 1 a perfect square?
Yeah.
Check it.
Yeah. Square root of 1? Yeah, no, it is.
It's 1. Square root of 10. Is it a perfect square?
No.
No. Square root of 1,000. Is it a perfect square? No. Square root of 10,000.
Yes. 1,000.
Oh, I see how it's a pattern.
No.
That's dope.
Okay. 5. If I have 10,000, that actually says 100,000. Oh, it should be 100,000. 100,000. Is it a perfect square?
No.
It is not. What about 1 million?
Yes.
It's going to be 1,000. Now, why does that work? Why are they not all perfect squares? What's the pattern?
Zeros aren't even.
The zeros aren't even. So let's take a look. What is 10 squared?
Hundred.
It's 100. Remember the zeros back to base 10? That's why we did that. What is 10 cubed? It's 1,000. Now, what is 100 squared? 10,000, right? Now here's a weird thing. What is 1,000 squared?
It's like a million.
It's like a million, man.
A million, dude.
So if we take this cube out, how many zeros do I have here? Are they odd or even?
Even.
Even. Even. You cannot make, here's a challenge, make 1,000 by multiplying the same multiple of 10 by itself.
10 by what? Or you like
10
10 times 10?
times 10. Square something to make 1,000. What would you square? 100 gives you 1,000. See how you're doubling the number of zeros?
You'd square 31.6227.
Yeah, but that's not a perfect square. Look here. How many zeros are here? When I square it, how many zeros do I end up?
4.
How many do I have here?
3.
When I square it, what do I end up with?
6.
That's why odd numbers of place values can never be perfect squares. I'll let that sink in. That's weird, eh? What would the square root of a million be?
10,000.
You cut these by half. It would be 1,000. Square root of 100, cut the number of zeros by half. It would be 10. If I have 8 zeros, 5, 6, 7, 8, and I square root,
4. 1,000.
cut it in half. It's going to be 10,000. It's weird, isn't it? Last thing. Someone just stole my piece of paper to make a hat. Grade 9. Just saying.
That's all you need to say. 8, 9.
I can't be happier.
It's awesome.
Mr. Paul's writing stuff down. Maybe I should pay attention. Okay. Say this number for me. And don't say 0.25, so help me if you say 0.25.
0.25.
You just failed math. No, I'm joking. Okay, what is it? Say it in place value. 25. Who said it? 25 hundredths. What's this one?
25,000.
Thousands. This one is
10,000.
25 10,000s. 25. Now it's going to come and bite you. It's not going to bite you. 100,000s. And this is 25 millionths. Okay, guys, if you're building hats, just don't interrupt, okay? This, guys, this is a huge piece of the grade 8 curriculum because if I have 100, can I take the square root of 100? Can I take the square root of 100 and get a perfect square? Why? Why?
Because of the
What's the square root of 100? 10. Of course you can. If I can divide the zeros in half evenly, that's a perfect square. Okay? In a bit. Can I take the square root of 1,000?
No.
I can't, right? That's going to be an irrational number. Does that make sense?
Yep.
Okay, stay with me, guys. So when we look at this, how many zeros do I have here?
1. 2. 2.
I have 1 0.
Why didn't you say that?
I have 1 0. Can you take the square root of something that has an odd number of zeros? So what is the square root of 25? 5. If I write 5 as a decimal with this, I'm going to get the square root of 0.25 is going to be 0.05. If I take the square root of this, this is going to be an irrational number. I can't split that in half. Place value won't let me. This one here, 0.0025. Well, I can cut that in half, can't I? I can take 1 0 out. Square root is going to be 0.005 because 25 to 5. This one here,